Hello. Hello. Hello.
Yeah, sir.
Yeah, fine. See the first question. See the first question. Four particles A, B, C, D with masses, okay, M, 2M, 3M, and 4M are placed at the corners of a square. They have accelerations of equal magnitude with directions as shown. The acceleration of center of mass. Hello. Okay. The acceleration of the center of mass we need to find. Hello. Fine. Yeah, fine. Okay. The first question. The first question. Four particles A, B, C, with masses, okay, M, 2M, 3M, and 4M are placed at the corners of a square. They have accelerations of equal magnitude with directions as shown. The acceleration of center of mass. Hello. Acceleration of center of mass, it is M1A1 plus M2A2 plus M3A3 plus M4A4. M4A4 by total mass, right?
Hmm.
Okay, now?
Yes, sir.
Okay, fine. Now, you can see here it is. So, first particle, we can write in the position vectors as first particle, we can write in the at A. That means here I am considering that is 0, 0. That is 0, 0. Okay. Okay. At A, it is 0, 0. From mass it is M1A1 plus M2A2 plus M3A3 plus M4A4. M4A4 by total mass, right? At, at D, that means its position vector it is 0 I cap plus 0 j cap. At point D, that is 0, A. At point C, A, A. Okay. At point B, it is 0, A. At point D, it is A, 0. So that means here it is 0 I cap plus A j cap. At D it is A I cap. At point C it is A I cap plus A j cap. Okay, na? Fine. So acceleration of center of mass, it is first particle. Okay, moving towards left. So first particle mass is M times A into minus I cap. Second particle mass is 2M, that is at B, times A into I cap. And Third particle mass is 3m. Okay. So it is ai cap. Fourth particle plus 4m. Okay. Fourth particle, it is moving downwards. So minus aj cap divided by total mass m plus 2m plus 3m plus 4m. Okay, na? Is it fine? Minus ma cap plus 2ma cap and plus 3ma cap. Okay. So it is 4mai cap minus 4maj cap divided by 10m. Okay, na? Fine. Hello. Okay, na? Hello.
Yes, sir.
Oh, okay, fine. At point B, it is j cap. So it is 2ma cap minus 2maj cap. So 2ma take common, I cap minus j cap by 10m. So it is a by 5 times I cap minus j cap. That is first option. Right? Fine.
Yes, sir.
Next one. Next question. Is it over?
Yes, sir.
Okay, fine. Next question. A thin circular plate of mass m and radius r has its density. Okay, that is rho is a function of radius or distance. That is rho naught times r, where rho naught is a constant. Moment of inertia of circular plate about an axis perpendicular to plate and passing through edge. Perpendicular to plate and passing through edge is a times mr square. We need to find the value of a. We need to find the value of a. Okay, na? Let us consider we are having a circular plate. We are having a circular plate of radius r. Of radius r. Okay, fine. We are having the density as rho of r equal to rho naught times small r. Moment of inertia I equal to a into mr square. Now observe carefully. Moment of inertia of circular plate about an axis perpendicular to the plate and passing through edge. Okay. Perpendicular to plate and passing through edge means like this. Okay. Fine. Along in this axis, I need to find moment of inertia. Along in this axis. So, moment of inertia, I can write it as dA equal to dm times x square. Okay, na? So, density equal to, that is linear density equal to mass by length. that is equal to dm by dx. Okay, instead of x, we are considering as r. They gave in terms of distance as smaller, na? Okay. Is it fine? So,
Yes.
dm equal to lambda times dr. Okay. So, it is lambda r square times dr. Lambda means density. That is rho r square dr. Okay, na? Fine, na?
Yes.
Is it fine? Okay, fine. So, di equal to, instead of this one, lambda times dr. Okay. We can write as dA equal to, I'll write as dm into x square, dm into x square, dm equal to density times, that is rho naught x, into length. Length of a circle, it is circumference, that is 2 pi x. Okay, into dx times x square. So, dA equal to rho naught into 2 pi x power 4 dx. Okay, na? Fine.
Yes.
Okay, fine. So, here it is, this distance is capital R and this distance it is smaller. That is inner ring it is smaller, outer ring it is capital R. So, the total moment of inertia dI equal to dm into x square plus dm into r square. That is 2 pi rho naught x power 4 dx plus 2 pi rho naught r square times x square dx. Upon integration, we'll get the total moment of inertia between values from 0 to capital R.
Yes.
2 pi rho naught r power 5 by 5 plus 2 pi rho naught r square into x cube by 3 between value 0 to r. That is 2 pi rho naught r power 5. Take common 1 by 5 plus 1 by 3. That is 2 pi rho naught r power 5 into 8 by 15. So, moment of inertia it is 16 pi by 15 rho naught r power 5. Okay. Now, we'll convert this into mass. They gave A into mr square. Okay. Fine. Na?
Yes.
A into mr square. Density, it is with respect to distance they gave na, m by 2 pi r. Total mass by total radius, m by 2 pi r. Fine. So, 16 by 15 into rho into 2 pi r. Pi r into rho naught multiply by 2 divide by 2. This is the total mass. This is the total mass. Rho naught into 2 pi r means. Okay. Into r power 4. So moment of inertia will be 8 by 15 into m r power 4. Okay na? M r power 4. Okay. So A equal to 8 by 15 r square, which is not there. Okay na?
Yes.
Right on. Okay na? Completed.
Sir, 1 minute, I am writing. Yes, sir, done.
Done. Okay, fine. Next one. A solid sphere and cylinder. A solid sphere and a cylinder. Okay, of identical radii approach an incline with the same linear velocity as shown in the diagram. Both roll without slipping all throughout. The two climb maximum height, H sphere and H cylinder, on the incline. The ratio of height of the sphere by height of the cylinder. Okay. So, suppose let us consider we are having the two objects. Number one, it is sphere, and number two, it is cylinder. Whenever it is moving, it will have kinetic energy. And whenever it is climbing up, it will have rotational kinetic energy. Right? So, total kinetic energy, I can write as half mv square plus half I omega square. So, for kinetic energy of sphere, I can write as half mv square plus half moment of inertia of a sphere means, can I write as 2 by 5 mr square? And omega, I can write as v by r whole square. So it is half mv square plus mv square by 5. 2 gets cancelled. Mv square by 5. Okay na? Is it fine?
Yes.
So kinetic energy of sphere will be, can I say it is 7 by 10 mv square. 7 by 10 mv square. Similarly, kinetic energy of the cylinder. Moment of inertia of a cylinder, it is, I can write it as mr square by 2 times omega square, I am writing as v square by r square. So it is mv square by 2 mv square by 2 plus mv square by 4. Okay na? Fine.
Yes, sir.
That is 3 by 4 mv square. 3 by 4 mv square. Okay, na? Three by 4 mv square. So kinetic energy we got now. Since potential energy mgh equal to total kinetic energy. So H sphere by H cylinder we need to find. So 7 by 10 mv square by 3 by 4 mv square. That is 7 by 10 into 4 by 3, which will get 14 by 15. That is second option.
Yes, sir.
Okay, na? Fine. Okay. Fine. Can I go to next question?
Yes, sir.
See the next question. A rectangular box of length 0.3 meter is held horizontally with one of its sides on the edge of a platform of height 5 meter. When released, it slips off the table in a very short time. Okay, time it is given as 0.01 second. The angle by which it would rotate when it hits the ground will be close to. Okay, we need to find the angle. Okay, that is theta I should find. Whenever, okay, the angle by which it rotate when it hits the ground, whenever it is rotating, it will have an angular velocity. Can I say? It will have an angular velocity. So whenever the solid box is rotating, so angular impulse of weight is equal to change in angular momentum. Okay, change in angular momentum. That is, angular impulse means we can say with respect to half, that is with respect to center of gravity, it will rotate mgl by 2. Okay, mgl by 2 times t. That is equal to angular momentum. That is angular momentum is I omega. Since it is a rod and rotating at one end, so moment of inertia means ml square by 3. So T into mgl by 2. So upon calculation, time we are having this one. Okay. That is T into G by 2 equal to L omega by 3. Okay. So from this, omega equal to 3gt by 2l. Okay, na? So omega equal to, let us consider g as 10, time as 0.01, length as 0.3. Okay, na? Is it fine?
Yes, sir.
Okay, so this is 3 into 10 into 0.01 means 0.1 by 2 into 0.3. So it is omega equal to 1 by 2, nothing but 0.5 radian per second. Radian per second. Now, since we know that theta equal to omega into t naught or some time t. So that means it is falling or rotating from a height h. So t naught equal to under root 2h by g. That is 2 into 5 by 10. That is equal to 1 second. In a time of 1 second, it will false. So it is 0.5 into 1, theta equal to 0.5 radian. That is option C.
Yes, sir.
Okay, na? Fine, na? Is it okay?
Yes, sir.
Ah. Can I go to next question?
Yes, sir.
The next one, it is a uniform rectangular thin sheet ABCD. A, B, C, and then D. ABCD. Of mass M has a length L, has a length A, and breadth B, as shown in diagram. If the shaded portion HBGO is cut off, the coordinates of center of mass of the remaining portion is the coordinates of center of mass of the remaining portion will be. Okay, na? Fine. Firstly, length it is A, breadth it is B. So area will be, can I write as AB? For shaded part, area will be A by 2 times B by 2. Okay. That is nothing but AB by 4. AB by 4. Okay. So initially, coordinates of center of mass of the shaded part, can I say as A by 4 comma B by 4? Here it is. Okay. So A minus A by 4, 3A by 4 comma 3B by 4. Okay. So by using the center of mass, xcm equal to a1x1 minus a2x2 divided by a1 minus a2. That is, initial area is AB and center of mass x1 means initial center of mass of the rectangular sheet minus AB by 4 times 3A by 4 divided by AB minus AB by 4. So xcm equal to A square B by 2 minus 3A square B by 16 divided by 3AB by 4. So A square B by 2 take common 1 minus 3 by 8 divided by 3AB by 4. Okay. So xcm equal to A square B by 2 times 4 by 3AB 3AB times 5 by 8. So upon calculation, we'll get as 2A by 3 times 5 by 8. That is 5A by 12. 5A by 12. Similarly, YCM, that is AB into B by 2 minus AB by 4 into 3B by 4 divided by AB minus AB by 4. So A B square by 2 take common 1 minus 3 by 8 divided by 3AB by 4. So AB square by 2 into 4 by 3AB times 5 by 8. Okay, fine. This is also equal to 5B by 12. That is second option. Okay, na? Is it okay?
Yes, sir.
Right on. Okay, na? Completed.
Just a minute.
Uh,
Yes, sir. Done.
Done, na? Okay. See the next question. A stationary horizontal disk is free to rotate about its axis when a torque is applied on it. When a torque is applied on it. Okay, fine. Like this, it is rotating. Its kinetic energy as a function of theta, where theta is the angle by which it has rotated. Okay, is given as k theta square. Okay, so kinetic energy equal to k times theta square. Moment of inertia is I, then the angular acceleration of the disk. We need to find alpha. Okay, so kinetic energy, I can say that half I omega square equal to k theta square. Okay, na? So omega square equal to 2k theta square by I. Omega equal to theta times under root 2k by I. Can I say? I need to find alpha. I need to find alpha. So differentiate, that is d omega by dt equal to under root 2k by I times d theta by dt. So alpha equal to under root 2k by I times omega. That is under root 2k by I into omega means under root 2k by I into theta. So alpha equal to 2k by I times theta. Okay, na? That is option D. Is it fine?
Yes, sir.
Write down. Okay, na? Completed?
Yes, sir.
Okay, fine. See the next one. It is the following bodies are made to roll up without slipping the same inclined plane from a horizontal plane. Ring of radius r, solid cylinder of radius r by 2, and solid sphere of radius r by 4. In each case, velocity of center of mass at the bottom of inclined plane is same. Okay. Suppose VCM equal to V only. Let us consider inclined plane. Okay. Having an angle of inclination theta. Okay. Initially, object is at here. Suppose any object, ring or cylinder and sphere. Okay. It is at a height initially. Whenever it is, the object is rolling. Okay. Whenever it is rolling, then what will happen? It will have both translational kinetic energy and as well as rotational kinetic energy. Right? That means I'll write initial energy as potential energy and final energy as rotational kinetic energy plus translational kinetic energy. Okay. So I can say mgh equal to half mv square plus half I omega square. Can I write? Okay, na? So it is mgh equal to half mv square plus moment of inertia means mk square. Can I write? Okay. Instead of omega, I am writing it as v square by r square. So in these two terms, I'll take mv square by 2 common. 1 plus k square by r square. Okay, na? So total energy, that is mgh equal to mv square by 2 times 1 plus k square by r square. Is it fine? So upon calculation, we'll get h equal to v square by 2g times 1 plus k square by r square. Per ring, what we can say, k square by r square equal to 1. So h ring, it is v square by 2g into 2. Okay, na? Fine.
Yes.
Similarly, for cylinder, okay, k square by r square. Okay. Here cylinder radius is r by 2. Okay. For cylinder, k value will be, okay, radius by root 2 whole square by r square. That is r by 2 whole square. So that is r by 2 root 2, 2 root 2 divided by r by 2 whole square. Okay. Fine. So for cylinder, it is, we'll get as 1 by 2 k square by r square value. So h cylinder equal to v square by 2g times 1 plus half means 3 by 2. That is 3v square by 4g. This is 2v square by 2g. Similarly, sphere, h sphere. Okay. Similarly for solid sphere. For sphere, k square by r square equal to 2 by 5. So height of the sphere it is v square by 2g into 1 plus 2 by 5. So 7v square by 10g. Now we'll put the ratio 2v square by 2g is to 3v square by 4g is to 7v square by 10g. In every term, v square by g will take common. 2 to cancel. So 1 is to 3 by 4 is to 7 by 10. 7 by 10. Okay. Fine. So multiply by 20 in each term. 20 is to 15 is to 14. Okay. Now they are asking to find the ratio of the maximum height they climb. Maximum height they climb. That is 20 is to 15 is to 14. That is, they are taken from the last. That is 14 is to 15 into is to 20. Fourteen is to 15 is to 20. Okay, na? Fine. Okay, na? Completed?
Yes, sir. Just a minute.
Okay.
Yes, sir. Done.
Done. Okay, fine. Next. A wedge of mass 4m lies on a frictionless plane. Okay. A particle of mass m approaches the wedge with a speed v. That means we are having a wedge. Let us consider this is my wedge having a mass 4m. Okay. Now lies on a frictionless plane. A particle, suppose I'm having a particle of mass m, approaches the wedge with a speed as v. There is no friction between particle and the plane or between the particle. The maximum height climbed by the particle on the wedge. How much height it will go? As the particle it moves, okay, it moves to a height. Suppose here, okay. Suppose this is my maximum height. That h value I need to find. That h value I need to find. Okay. Now, see here, as the this particle mass m collides with the wedge, then what happens? Both wedge and particle will move with a speed. Let us consider as the particle collides with the wedge. Wedge and particle moves with an velocity or speed as, let us consider it as v2. Initially, particle is moving with a speed v. Wedge is at rest. So by applying law of conservation of linear momentum, it is m into v plus 4m into 0 equal to 5m times v2. Can I say? So v2 equal to v by 5. Okay. v2 equal to v by 5. So initially, before collision, energy it is half mv square is equal to half m v2 square, and particle rises to a height h plus wedge is also moving with a velocity v2. Right? Okay, na? So it is multiply by 2 on both sides. mv square equal to mv2 square plus 2mgh plus 4mv2 square. I need to find h. Okay. And I know v2 value. I'll substitute here. That is mv square equal to mv square by 25 plus 2mgh plus 4mv square by 25. So upon solving, we'll get as mv square equal to 2mgh plus mv square by 5. So 2mgh equal to 4mv square by 5. Okay, na? So h equal to 2v square by 5g. That is option C. Okay, na?
Yes.
Hmm. I'll send this document, ma.
Okay, sir.
Okay, once you try. Okay, na?
Yes, sir, I'll try.
After class, I'll call you.